Okay, welcome back. It is day 198 of coding every day. Um, so today went to the lab again, worked both days on the weekend, um, and looked more into the Wi-Fi thing for my research. It's just the biggest problem, honestly, is the simulation. Like I said yesterday, it's like I can't signal Wi-Fi waves in the scene, and even if I do like a lot of ray tracing, it lags anyways. So like even like at that, it's not working. Um, but I kind of mapped out the general like premise of like what I want, what I'm looking at. Maybe I'll put an image on up right now of what I did on the whiteboard today in the lab. But it was basically just the idea is that when the Wi-Fi sends its signals throughout the room, we have an Intel 3500, which is one of the only things that it seems was ever made that can actually give us the information of the CSI information about like I think it gives like two key things, which is like amplitude and like kind of in a way, I think like the path, like the length it took from sender to receiver. Um, but the idea is only to use the amplitude. So, from my understanding, that is like if you sent out a signal at 1 volt and it got it at like I think it's like one volt sine wave is what the terminology. Um, and you got like a zero point zero 0.02 volt sine wave. Um, you look at that value and then well actually you have 30 different signals at different frequencies that are sent out, and so all of them take a different path, so you get like 30 different amplitudes per packet that you receive, and a packet's like I think point 0.1, no, maybe it's like I don't know, but just per packet. And you look at all the amplitude readings, and then it's like a time series of each packet. That signal ideally should stay the same, right? Like the same amount. It's the same. It takes the same path, so the amplitude's the same, or at least very close throughout a time series of maybe a few thousand packets, and you can kind of get like a baseline. And then if you were to move through all the waves in the room, the amplitudes would change, and hopefully that's it. Like it would change in a pattern that you can recognize. Like, well, actually, the big thing is it's not like a pattern. I mean, I guess it's like a pattern, but it's a Doppler effect. So it's like let's say there's no waves, you remove the noise, so you put it through like a some type of filter that like if you just have it in a room and nothing's happening in the room, it would be at like a baseline of zero. Okay, no wave. And then it's like if you walk through the room, then there is a wave that like forms, whatever wave that may be. I don't know what wave it would form, but then you make a table that is like the Doppler confidence table, and so it's like from 1 to 128 waves. So 128 waves would be there's a fucking like bird flying in the room. I'd assume like a lot of movement very fast. And then like walking through a room might be like one or two waves within that frame. And a frame is like 10 seconds of time or something like that. So yeah. So you'd look at that and then train a model to like based on those amplitude readings be able to detect what movement's happening in the room. So yeah, we'll see. I actually ordered I actually ordered the stuff to do it in a room because it wasn't that it was like $50 altogether. And it'd be nice to just take it home. Like I could have asked the lab to it, but it'd be nice to take it home and just like I like working on hardware stuff anyways. Um, so yeah, so I'll keep you updated through the week how that's going. Um, as for coding today, I did one easily code that was literally, I mean, behind me. It's in real time basically because it only took me 5 minutes. It was um, just making a frequency thing of characters and then returning the most frequent thing after sorting it. So, and then I looked at the solution, which was all I had to do was sort it and then take the value at pretty much the halfway point. So, okay, that's all I have. I will see you tomorrow for day 199. Take care. Bye.